Welcome to our presentation on the renin-angiotensin-aldosterone system, also known as RAS. First, let me introduce you to Mike, a 22-year-old student. We'll come back to him later. The RAS system plays an important role in endocrine, paracrine, and intracrine hormonal systems in the regulation of blood volume, cardiac output, and systematic vascular resistance, which together influence blood pressure. The system is triggered after a drop in blood pressure, which can occur due to dehydration, blood loss, illnesses, and medications or sodium deficiency. Blood pressure is regulated through neural mechanisms from the cardiovascular center by managing cardiac output or adjusting blood vessel diameter, or the kidneys provide a hormonal regulation of blood pressure by managing blood volume. The RAS system is comprised of numerous organs, hormones, and enzymes, and is constructed of three main components, these being renin, angiotensin, and aldosterone. The negative feedback loop begins in the kidneys, which are essential for removing waste products from the body, absorbing and balancing the body's fluids, and releasing hormones that regulate blood pressure. The kidney is comprised of a filtration system of nephrons. These consist of the capsule enclosing the glomerulus and feeding the filtrate into the tubular structure, which includes the proximal tubule, the descending loop of Henle, the ascending loop of Henle, and the distal convoluted tubule. The distal convoluted tubule contacts the juxtaglomerular apparatus, which contains juxtaglomerular cells, and its main purpose is to detect changes and regulate blood pressure in the nephron. It is also responsible for the filtration rate in the glomerulus. Juxtaglomerular cells secrete renin when blood pressure drops and is detected in the efferent and afferent arterioles. Renin is secreted from the juxtaglomerular cells into the blood in response to rising blood pressure. Angiotensin is a plasma protein that is secreted by the liver and is constantly in the bloodstream. Renin cleaves angiotensin to form angiotensin 1. Angiotensin converting enzyme is mainly found in the lungs, however it is present in the brain, heart, adrenal glands and kidneys. It converts angiotensin 1 to angiotensin 2 to become biologically active. Angiotensin 2 binds to many receptors in the body to affect several systems and help maintain homeostasis. It can increase blood pressure by constricting blood vessels, vasoconstriction, and triggers centers within the brain, activates the adrenal cortex to secrete aldosterone and other mineral corticosteroids that act on kidneys to increase sodium and fluid retention, and stimulates the pituitary gland to produce antidiuretic hormone, which stimulates water reabsorption. All of these angiotensin 2 triggers aim to increase blood pressure. Now coming back to Mike. Say he's just finished exam period and wants to celebrate with a few drinks. Alcohol can impact the renin-angiotensin-aldosterone system by increasing plasma renin activity. This results in increased production of angiotensin 1, which is converted to angiotensin 2 by the angiotensin-converting enzyme, as described previously. Angiotensin 2 constricts the blood cells and stimulates aldosterone secretion from the adrenal gland, which increases sodium and water retention. As a result, vasoconstriction and blood volume increases, leading to higher blood pressure. Alcohol also inhibits the posterior pituitary gland from secreting antidiuretic hormone. When ADH drops, the kidneys do not absorb as much water. Consequently, the kidneys produce more urine and may lead to urinary incontinence. Thanks for listening to our presentation.